Hello, ladies and gentlemen. My name is Abdurrahman Ali. Inshallah, today I'm going to solve question number 3 in lecture number 6 for beams in mechanical of materials. So the question says, draw the shear and bending moment diagrams for the beam and loading shown and determine the maximum absolute value of the shear of the bending moment. So he is looking for Vmax and moment max. Okay, so how to solve this question? First of all, we have to draw our FBD. So it's going to be like this. It's 2K. This is B. This is E. This is D. This is C. This is A. So B, E, D, C, and A. Okay, this one is 5K. This one is 2K. And this one is 3K. And we don't know AY and AX. And we know the moment is like this, MA. Sorry guys, this one is MA. And we have 0.4 meter. We have also 0.3, 0.3, and 0.3. All meters, meters. So now let's start with the summation Fy equal to 0. So we know this one, fx. So we need to know fx first for for ax. So it's gonna be minus ax equal to 0 because there is no other forces on the a-axis. So ax we know it is 0 kilonewton. Okay, now the summation in Fy equal to 0. We know that Ay minus 3 because it is downward, and also minus 2 because it's downward. We know this one is 5K, so it is up, so it's gonna be 5, and we have downward, it's gonna be minus 2, all equal to 0. So Ay equal to 2 kilonewton. That's Ay. Now the summation for moment at point A equal to 0. So we know it's minus 3 times 0.3 because it is far away from that one, or the distance, minus 2 because it's clockwise, so it's gonna be minus 2 times 0.6, which is the distance from that moment A, plus 5, and it is 0.9 distance minus 2, and it is 1.3, okay, far away, then plus MA equal to 0. So if we bring MA outside, MA equal to, multiply all of them, you're gonna end up with 0.2 kilo Newton per meter. So this is MA. Okay, so now let's go and find all the forces at part B, or part the first part, which is part AC. So the FBD is going to be like this, 0.2. Okay, that's the moment for it, and we need to find the moment for the point C and point A. Okay, we know AX is 0 here, and we know VY or VA is equal to 0.2. So now the summation of all forces at Fy equals 0. It's gonna be 2 minus V equals 0. So VA equal to 2 kilonewton, and the summation of M equal to 0. So we have to look for that one. It's gonna be minus 2 times the distance plus 0.2 plus M equal to 0. So M equal to 2 times 0 minus 0.2, y times 0, because we know AX is equal to 0, so 2. Okay, now M equal to minus 0.2 kilonewton per meter. This is MA, and we know MC. If you put this value in the other equation, so we know that MC is equal to 0.3 minus 0.2. So MC is gonna be 0.4 kilonewton per meter. Okay, that's for part A. Now let's go for part CD. So the FBD for part CD, C, this is D. You know, this one is X. We know the moment, and we know that one is 0.2, and we know it's 3. We know this part is 0.3 meter. So now let's find all the summation in Fy equal to 0. Okay, we are having 2 minus 3 minus V equal to 0. So V equal to minus 1. This one actually VD. Okay, VD. It's gonna be minus 1 kilonewton. Okay. So now let's solve for the summation. of m equal to 0. So we know it's first 0.2 minus 2 x, because we don't know it, plus 3 times x minus 0.3 plus m equal to 0. So we know m equal to minus x plus 0.7. So we know that now x is 0.3, so now m equal to minus 0.3 plus 0.7. So MC is going to be 0.4, okay, kilonewton per meter, and MD is going to be minus 0.6 plus 0.7. So MD equal to 0.1 kilonewton per meter. So now for the third part, okay, part DE. So the FBD is going to be like this. 1, 2, 4. Okay, sorry guys. And now let's solve for Fy equal to 0. So we know all this forces. So 2 minus 3 minus 2 minus V equal to 0. So V equal to minus 3 kilo Newton. Actually this is VD, and VC also the same, they are minus 3 kilo Newton. Okay, now let's solve for the summation of all moment. So it is like this: 0.2 minus 2 times x plus 3 x minus 0.3 plus 2 x minus 0.6 plus m equal to 0. So after multiplication all of these, we end up with m equal minus 3 x plus 1.9. So moment at D equal minus 3. We know x at D is 0.6. Okay. Plus 1.9 equal to 0.1 kilo Newton. Okay, this is for MD. Now for MC, or sorry, for ME, we know it's minus 3. and we know ME is located 0.9 plus 1.9, so it's gonna be equal to minus 0.8 kilo Newton per meter. This is ME. And for the final part, we are going to solve for EB. So EB, now if we draw the free body diagram for it, it's going to be like this. It's 2, and we know it's 1.3 minus x, and we need to find V, and we know the moment here, or we need to know the moment here. So now the summation of Fy equal to 0. So we know V minus 2 equals 0, so V equal to 2 kilo Newton. Okay, and we need to find the moment. So summation of all moment equal to 0. We know it's minus 2 times 1.3 minus x equal to 0. Sorry, plus m equal to 0. Okay, sorry, minus m. Okay, so m is going to be equal to minus 2.6 plus 2x. Now for the moment ME, it's going to be equal to minus 2.6 plus 2. We know the moment at E, that it's located 0.9 meter, so it's going to be minus 0.8 kilo Newton per meter. And for MB, equal to minus 2.6 plus 2. We know x, or it's located 1.3. Okay, so MB is going to be 0, because minus 2.6 plus 2, 1 point. This one is also plus 2.6, so it's going to be 0 kilo Newton per minute. So guys, he is looking for Vmax. Okay, so when we go back again and to see which one is the highest V, we found out is VD and VC, which is 3. So Vmax is gonna be 3 kilo Newton, and it's the absolute. And for moment max, the maximum, this one is gonna be ME. ME is the highest, which is 0.8. So 0.8 kilo, because it's absolute also. So it's gonna be kilo Newton per meter. So we did find the Vmax and moment max by this solution. And now we need to draw our diagrams for the shear and for the moment. It's going to be like this. This one is -1, this one is -3, because it's our Vmax. And we have 2. This is on the x-axis and this is on the y-axis. And this one is drawing for kilonewton. This is our V diagram, which is the shear. Okay, now let's go and to draw the moment. So our moment is going to be like this. We are having the first point, and we are having our second point here, and then we are having our third point, which is here, and our fourth moment is going to be here, and our last moment is going to be here because it's 0. So when we draw, I'm going backward, guys, because I will put the numbers now. And you will understand, inshallah. So we are having -0.2, we are having 0.4, and here we are having 0.1. This is our moment, guys, for the points, which is A and D, you remember that one, and -0.8, and our last moment, which is 0. This is our diagram for the moment, guys. In kilonewton per minute. Thank you guys for watching. I hope you enjoy. Inshallah, see you next time.